Okay, so what we're going to do in this lesson is tear through 6a, b, and c, and really all this is going to be is a review of circular functions. So hopefully we'll dust off the cobwebs and get you ready to go for what will be the more sophisticated applications of trig, which is certainly when we start to derive sine, cos, and tan graphs. All right, so let's just go back a little bit. Diagram shows a unit circle, and what the unit circle is a circle of radius 1 unit. So the distance from the origin to this point here is 1, okay? And it will be the same radius all the way through because, well, it's a circle. Now, if you recall this formula here, circumference equals 2 pi r, or circumference equals pi d. So all we do to get the circumference or the distance around this circle here is slam our radius in, which is 1 multiplied by 2 pi, means that the distance around the unit circle from A through to A itself is a distance of 2 pi. And that's going anti-clockwise, so going in this direction here. What is the anti-clockwise distance from A to B? So we're going from here all the way around and stopping here. So what that is, that represents 3/4 of the full distance, so 3/4 of 2 pi, which is 6 pi on 4, which is 3 pi on 2. You can also think of it like this. The distance from A to D is pi on 2, okay? The distance from D to C is also pi on 2, and the distance from C to B is pi on 2. So that would be pi on 2 plus pi on 2 plus pi on 2, which will be 3 pi on 2. All right, A through to C. So if the distance from A to A is 2 pi, then the distance from A to C is going to be half that distance. So 2 pi over 2, which is equal to pi. And finally, the anti-clockwise distance from A to D. So if I know that the distance from there to there, A to C, is pi, this is going to be half that distance again, so that's pi on 2. All right, so note that your calculator can be in either radians or degrees. So if you look at my calculator here, I'm in radians mode, and that's generally speaking the mode that you want to be in for methods, but there'll be absolutely some questions that need you to go into degrees mode and then require you to remember to slam it back into radians mode. Avoid GRA mode or gradient mode. That sometimes gives you quite similar answers, or what you might deem appropriate answers, but they'll be wrong as well. So you want to check those modes, rad or deg. Okay, so what is 1 radian? Well, a radian is the angle subtended at the center of the circle by an arc of length 1 unit. So this one here, if I grab this one here and wrap it around the unit circle, that's what we call a radian, this distance here, okay? So the way to think about how that could be acquired is, you know that the full distance around here is going to be either 2 pi or 360 degrees. So 360 is equal to 2 pi, okay? Now, this here represents the radians and this here represents the degrees. So 2 pi radians is the same as 360 degrees. Now, if I divide that by 2 pi and divide that by 2 pi, what I get is 2 pi over 2 pi is simply 1, and 180 over pi. So 1 radian is equal to 180 over pi. Now, pi is roughly 3. So 180 divided by roughly 3 is 60 degrees. It's going to be a little bit more than 3, 3.1. So that'll decrease that. I wonder by how much. So we're going to do 180 divided by shift 0. And let's get an approximation on that. And surprise, surprise, it's 57.29 degrees. Okay, so 1 radian is roughly 57.29577 degrees. All right, so what we want to do is convert some degrees to radians. So here we've got 30 degrees, okay? And what we want to do is convert them to radians. All right, so how do I do that? Well, I know that this is the case. 360 degrees is the same as 2 pi radians. So I want to work out what 1 degree is. I'm going to divide that by 360 and divide that by 360. That cancels out to be 180. 1 degree is pi on 180. So all I need to do is multiply 30 by pi on 180. That's once, that's 6. And hopefully you'll remember from last year that that's pi on 6. Pi on 4 to degrees, so we've already got this, okay, so we know that we've got the amount of radians here, we want to convert that to degrees, so all we're going to do is pi on 4 times 180 on pi. Cancels 1, no, was it 1, 2 and 90, yet 145. Okay, so that is 45 degrees. So pi on 4 radians is the same as 45 degrees. And this is basically how we convert. So if 1 radian is equal to 180 degrees on pi, then 1 degree is equal to pi on 180. We use that as the conversion mechanism. So using the diagram right, how many degrees is 1.64 radians? So here's 1 radian, here's 1.1, 2, 3, 4, 5, 6. It's roughly there. So I'm going to say roughly, I don't know, like 91 degrees. On the diagram right, how many radians is 135 degrees? So 135, this is 90, 135. So I'm going to guess 1, 2, 3, 4, 5. I'm going to guess 2.5 C or radians. Confirm your approximation in A and B with a calculator. All right, so let's just do this one on the calculator. Okay, so the way I'm going to do this, I'm going to jump over to the calculator and I'm going to go 135 multiplied by, and so what I'm doing is converting that to radians, so it's going to be shift pi on 180, which is 2.35. Okay, so the guess for B, 135 degree is approximately 2.356, which, you know, that was my guess, it's not too bad. And we'll do the first one, which is 1.64 radians multiplied by 180 on pi, and we get 93.96 degrees. 93.965 ... degrees, which again, that was my guess using this rudimentary unit circle with radians marked in, so that wasn't too bad. Okay, so off you go on 6A.